You're listening to the Struck Podcast. I'm Dan Blewett,
I'm Alan Hall.
and here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Podcast. On today's episode, we've got a bunch of topics. First, we're going to talk about Boeing and their assessment of hydrogen power, which they think it's going to be a pretty difficult task to get up to speed there by 2035. We're going to talk about the 737 MAX. An FAA administrator has committed to flying that plane coming up soon. So we'll chat a little bit about the implications there. There's also another hydrogen-powered passenger plane from Piper that took its maiden flight. And a recent A320 was struck by lightning in New Zealand. So we'll chat about that. In our engineering segment, we're going to talk about the GE9X jet turbine engine. It's going to be used on the 777X, the 777. Such a big engine, the biggest in the world. So we're going to talk about that. Also incredibly fuel efficient. And lastly, in our eVTOL segment, we're going to talk a little bit about the Embraer X concept, but overall, we're going to chat about the state of the industry in general. So, Alan, let's jump into it. Boeing thinks hydrogen is going to be difficult. Why?
Because you have to redesign everything. And when I mean redesign everything, I mean redesign everything. You're going to probably start with a different looking airframe. So you're probably talking a blended wing type of design, which NASA was working on for years ago and Boeing was involved with in some of those, in which Airbus is also talking about now. Go figure. Mm-hmm. And every other piece of fuel system on that aircraft will have to change. And that includes the engines because the fuel burns hotter. All the plumbing and all the safety features that go into making sure a fuel system works properly and doesn't endanger the aircraft will have to change. And that means plumbing, clamps, brackets, valves are working at way different colder temperatures. You got to worry about condensation and frost and embrittlement and all the things that come along with working with a very cold fuel. You'll have to redesign the system. So what Boeing is saying is, guys, industry, do we realize that it's not as easy as like flicking a switch and we can just basically plumb in hydrogen into this existing architecture because it won't work. Mm-hmm. And we have to start over. And starting over on engine development, which is tremendously expensive, to fuel system design and structural components and leak detection and all those things that we do have to be starting over. And mm-hmm. we don't have a lot of history with any of those systems. And the companies that would make those systems, like a Parker, or you name one of the fuel companies that, Parker being one of the bigger ones, is that how they gotta learn how to do that. So every part of the industry, no matter what tier you are in the aviation world, from Boeing being the tier one, and then all the suppliers down to little companies like our company, will have to rethink how they do everything. And that just costs billions and billions of dollars, and the time frame just gets thrown out the window. What Airbus was talking about was by 2035. That's 15 years. I'm not sure if you started today and started putting in the billions of dollars, you could do it in 15 years to the safety level that our passengers and our flying public expects today. So I think Boeing is being a little more realistic about it and saying, yeah, we got to take this with, we will definitely try to improve the reduce the amount of emissions that are coming from aviation. Boeing's 100% on board with that. So is Airbus. So is everybody. But I think what Boeing is trying to say is there are other ways that we can address this that don't involve dumping all the knowledge and the safety we've already developed over the last 60, 80 years and starting over. That's a pretty good take. And I think Boeing's taking a more staged response to it. It would be similar to, and I'm going to use an analogy here, but it's similar to the electric vehicles, where now it seems like, well, Tesla's making all these electric cars and General Motors is going to make electric cars. Everybody's going to make electric cars. But you got to remember all the other companies that were making electric cars that failed from the 1960s and 70s and 80s to today, there were multiple generations of cars that never made it. And what Boeing is sort of saying is that we don't have that in aviation. We don't have that sort of build up over time so we can work out the details that's on a smaller level, on a smaller scale. We're just going to we're going to start making equivalent to 777 airplanes out of hydrogen. That is, history would say that is not a successful way to go about it. The best way to go about it is to start off small and single engine aircraft, figure out how to do it there, scale it up, get the architecture figured out, do that sort of development work, which is going to probably take 20 years or more, and then get out to that next level. That's why hydrogen is going to be a struggle for aviation, I think, is that who's going to write the check for that? I don't know.
Yeah, the incrementalization seems like that's the key, because like you said, I mean even an aircraft, to get here with jet fuel, been using that for 70 years. And there's been a lot of learning over that time. And then, like you said, to throw it all out just on the biggest scale at the commercial airliner level, that seems, like you said, it's like a baffle. How many parts are in a commercial airliner? When you're talking about every one of them having to be newly certified for hydrogen, that seems terrifying.
Yeah.
That's crazy.
Yeah, it is. And when Airbus took on the challenge, I thought that was really aggressive. And okay, we're all up for a good engineering discussion and fight. And I think if you challenge engineers with a goal, we're going to try to get to it. But that challenge comes with a cost, and how many bodies and how much time you're going to have to devote to this to get to something that's even remotely as safe or reliable as what we have today. 30 years, 40 years, track records would say it's going to be that kind of time frame. Mm-hmm. We're not going to do it very quickly.
Gotcha. Well, speaking of which, the Piper M-class aircraft made its maiden flight recently. This is a hydrogen fuel cell plane. And is this the incrementalization that you've talked about? Is this basically the start of all that?
Yes, because they've had a Piper Malibu is a when it comes from Piper, is a turboprop airplane. So it's got a longer nose on the thing. And what they've done is first they took out the fuel system and taken out all the stuff that involves the standard turboprop engine, put in batteries, put in an electric motor, and then they had this sort of like this empty space behind the electric motor up in the nose. Well, so they've been flying around with the electric motor for a while, no sweat. What they have done now is they've taken basically a hydrogen fuel cell and just dropped that into the space where the turboprop engine was. Mm-hmm. So they have hydrogen fuel tanks on there and a system to convert the hydrogen and the oxygen from the atmosphere into electricity, which then powers the rest of the system. So that is an incremental step to do it. What we haven't heard yet is what the weight of that system is, the cost of that system is, and is it scalable? And what does it look like upscalable? Because that's the only thing that matters. If you can do it on a Piper Malibu, that's great. And I think it's a big step forward, honestly, for the engineering side. But when we're talking about demanding that Airbus produces hydrogen airplanes, there's a huge leap from a single engine aircraft, electric aircraft, to an Airbus A320 type airplane. So you can just see the progression in your head where, all right, we get this hydrogen thing working. We're going to try to reduce its weight, reduce its cost, and make it more efficient. All those things have to happen first. You go from a single engine turbo prop type airplane to a twin engine to something bigger like a Dash 8 or an ATR 4272 or a Q400. And that's your next level up in terms of turboprop airplanes. Try to get those up and running, and then what? What's your next leap, right? Mm-hmm. I don't know. Because in the way that system is set up, it's an electric system, and the only way that system works is with a propeller. It doesn't burn fuel like a jet engine does, so it's only going to go so fast, so you're kind of stuck into the turboprop world. How scalable it is, it has really no impact on the sort of the 737 Airbus A320 because those things burn fuel, and this thing is a turboprop. So it's not going to be relatable in terms of the way they're going to do things. But it can be that sort of that first step. It can be, yeah.
Yeah, it says it only goes up to 87 miles per hour. So, yeah, definitely in a different class than commercial travel for sure.
Right.
Yeah. So let's talk about the 737. So a FAA administrator has completed the joint operations, or is completing the Joint Operations Evaluation Board, like standards, the training, and then he is going to fly this plane. This FAA administrator, Steve Dickson. So what does this mean for the 737 MAX? Is this a standard procedure that happens in getting a plane back, or is this kind of a little bit abnormal?
Well, it's really abnormal. The FAA administrator, well, one, he's a pilot, so he can fly this airplane, but it's mostly feels like a confidence factor. Like if the FAA administrator is willing to fly in it, then why are you not willing to certify it? EASA, Transport Canada. That's what that's trying to say, is just as a public relations thing. When it comes down to it, who flies the airplane during the flight test doesn't really matter. What everybody on the engineering side and the certification side is going to say is, does it meet the regulations? Does it meet the intent of the regulations? Can you show me that it has systems in place to prevent what has happened previously? And until that's done, everybody's comfortable with that, then the 737 is going nowhere. Now, it seems like they are imposing additional checks and other things besides the mods that we made, and one of them is basically an angle of attack sensor check, which makes sense to me since that seems to be a real problem child, and some also minimum equipment lists, what things have to be worked on the airplane before you can take off, right? So not having a functioning AOA was like one of those things you couldn't fly with. So there's a lot going on behind the scenes that we're not seeing clearly. Now, the COVID-19 is sort of buying Boeing some time, but they want to get that thing, the 737, certified as fast as they can. And if it takes the FAA administrator flying in it to get over that threshold and to build confidence, then Boeing's going to be 100% for it and just going to go off and do it. I'm really looking for, I'm looking for by the end of this year that 737's done. They're making the mods in the airplanes that already exist on the ground, and they're going to start making some deliveries. That's where they have got to go to get moving again.
Gotcha. So Air New Zealand, an A320 on flight NZ696 was struck by lightning, and there was a travel editor on board, and he said it happened really fast. Most passengers probably didn't even notice it. People with their noise canceling headphones were just happily, oblivious. What do we need to know about the A320 being struck, and is this just a pretty run-of-the-mill just reporting because it's interesting, or is there anything to know about it?
Oh, I think it's interesting that Australia and New Zealand publish lightning strikes to the aircraft relatively frequently, and that they're happening in other places around the world, but you don't see news articles about them. So I don't know if it's just things are slow in the newsrooms in New Zealand and Australia,
slow news cycle,
yeah. I mean, or is it just that the flying public is more aware of it, is more concerned about it, or lightning strikes are more of a hazard in the country, so everybody's just a little more interested in what happens there. But every time you read an article from Australia and New Zealand, it says there's some airline representative that says essentially this: hey, the airplane's designed to take this. Lightning strikes to aircraft are routine. We did the inspection that's required, and we're going to put the aircraft back in service. That's essentially what they all say. So they have a canned response from the spokesperson on these lightning strikes. I just think it's interesting, and I wish that we had a little more lightning strike type reporting in the United States, because aircraft are getting struck in the United States and in Europe all the time.
Yeah.
But you just don't really read about it unless it's some significant level of damage, because I think the flying public doesn't realize that if you fly regularly, that you probably have been in an aircraft that's been struck. And Dan, you're right about people not noticing that they've been struck by lightning, because in most cases it's not very loud. And it may be somewhat of a flasher, but if you're not paying attention to it, you may have missed it. And so having somebody on board saying most people didn't even notice it is right. I think that's right. So probably a lot of people that have been in an aircraft that's been struck by lightning don't even know it.
All right, in our engineering segment today, we have got an engine to talk about. So the GE 9X is what they're touting as the world's next great engine. And this thing is enormous. It doesn't seem as deep as typical jet engines, but it's as wide as a 737 body. So that's as wide as the entire cabin, which is crazy to think about. 134 inches in diameter for the fans. And it looks like GE's they've got orders for 600 of these. So, Alan, what plane is this going to be on, and who's buying these, and why are they upgrading, and why the big deal behind this new engine?
Well, the engine is designed, at least for now, for the Boeing 777X, which is their composite wing advanced 777. So it's the newest 777, which is flight test program has been kind of shelved temporarily. But GE designed a very efficient engine for that aircraft, and every generation of engine is more efficient than the previous generation. And you go, well, how much can you drive down that efficiency chain? Well, we're finding out now that we can really drive that efficiency chain and reduce emissions out of these engines by making the fans larger. So you've got a hot section in the middle, which is the jet engine part, and then you have this enormous fan on the outside. And when you look at the engine, it looks stubby, short, because the fan is so large relative to the length of the engine. So it actually looks, its proportion's not right. So if you ever remember back in the 70s on the original 737, the engines were essentially all jet engine, all hot, and it was like a long cylinder. And now it looks like this, like a frisbee on one end. It's kind of what the engine looks like. But GE has been doing amazing things with aerodynamics on the fans and the fan blades, and also additive technology to improve the efficiency and the burning of fuel in the engine, so that they reduce emissions, increase performance. And I think, Dan, and you check me if I'm wrong, but I think that engine has like 130,000 pounds of thrust. So isn't it the largest thrust producing engine? I think that's right. I know it's close. The engine for the 787 was close. So it's a bigger engine clearly. And I saw this engine when we were down in Tucson, Arizona. They were installing the engine on the 747 platform to flight test it. So it was next to the Air Museum down at Tucson's, and like on the next hangar over. So you're looking at the back end of the 747, and you say 747 engine, gigantic, huge engine, 747 engine. It just dwarfed the 747 engines. It's hard to describe how big that engine diameter is. It's enormous. It's enormous. So, I always think the 777 is a large aircraft to begin with, and it's getting bigger, right? Because it's going to have the fold-up wingtips coming on with this new version. But when you look at this, when we were looking at that engine that day, looking through the fence line, you're like, wow. Everything about that engine has a lot of engineering involvement in it, from the fan blade shapes to the shape to the, you could just tell that they have spent oodles and oodles amount of engineering time squeezing out every last possible ounce of efficiency. And if you compare that to a jet engine from the 1960s or 70s, they're not even close to one another in terms of how they will operate in today's world. So when the 777X gets up and going again, we're gonna get a better feel for how that engine performs. But I'm really interested to see, like we talked about efficiency and other things, what does the next generation look like if we've gone this far? Because I can't. If the fan diameter is a 737 fuselage, what's the next one?
Yeah,
it only gets bigger, right? It only gets bigger, which means that you got to jack the airplane off the ground higher so you can stick this engine underneath the wing so it doesn't scrape the runway. because it's the fan size. If you see the pictures of the 777 of that GE9X engine on the 747 platform, you go, wow, that engine is huge.
Yeah, well, I mean, what are they going to have to start? I mean, are they going to have to start engineering the wings differently to accommodate bigger engine sizes? I mean, are they already putting more bracing into them, or are they already ready to handle a ton of weight as it is?
That's a really good question. Well, one, because you have to generate so much thrust, you got to be able to handle that thrust load. And then there's some issues about if you're kind of flying sideways, if you're not quite flying with the aircraft against the wind, you got this sort of side load on the engine, so you got some twisting that goes on there. You got to be able to carry those loads. I think, yeah, you have all those problems, right? You have the thrust problem, the side load problem, the vibration problem, which is a big one. If you lost an inlet fan blade, it's going to what they call windmill, and it's going to shake itself, and it's got all this icing testing that you have to do. So it does change the way you design the wing, and the 777X is a composite wing, so they can put a lot of structure up in there to hold this thing. I wonder because when you raise that point, because I wonder what they did with the 747 test bed, if they ended up doing a lot of structural changes to that aircraft to support the weight of that new engine, of the 9X engine, before they did it. So they may have spent a lot of time, and you're right, you put a much heavier engine on it, it's got a lot more thrust, you get the wing to be able to carry it. It does add to the complexity of the system. Sure it does.
Yeah, of course they said it doesn't have to be heavier when the engines get bigger. So they said the GE9X is actually not that much heavier than it's definitely heavier than the GE90, but you know, they used composites and a bunch of carbon fiber 3D printed parts, and so they went to a lot of lengths to keep weight down where they could. Yeah. Can you speak a little bit to some of these materials? So they're talking about ceramic matrix composites that can still hold their strength and their hardness up to 2,400 degrees Fahrenheit. So it sounds like heat is a really major limitation in the way they design and build these.
You want to burn hotter to have less emissions. So you want to make sure you burn every piece of fuel that comes through it, and then get as much thrust as you can out of that hot section. So that means you're probably going to run it hotter. And when you do that, all the components, all the fan blades, all the little pieces inside that engine have to work at higher temperatures. Mm-hmm. And what that means is you're leaving the metal world and getting into the ceramic world, and that's not an easy thing to do. And so they're making additive parts in ceramic because of the temperatures. So, as I was saying before, what's the next generation look like? What comes after ceramics? Yeah. Well, I don't know. Right, because you've all of a sudden you're sort of at that top level of materials. There isn't, at least to my knowledge, there isn't at the next stage besides just refining what you've already done. Maybe that's the plan, but you're sort of there right now. It's what's the curve for like the computer chip industry where it grows exponentially?
Yeah, I can't think of the name for that effect, but you're right. Like, I mean, just like with anything, even with human performance, like, you know, sprinters in the Olympics, like no one's beating anyone by more than, you know, a couple hundredths of a second now. So it seems like every technology is starting to get to that point. So
it starts to flatten out, right? You got this rapid ascent as you learn how to do this thing, and then it tapers off, and so you're starting to feel like on some of these engines that we're starting to get into that taper off point.
Mm-hmm.
So what's next? And it's the what's next I keep waiting to hear, and I haven't seen it yet. And maybe it's the sort of the scramjet, high, Mach 1 plus engines, whatever those things are going to look like. Who knows? But we're going along for the ride.
All right, in our final segment here today, we always we chat a lot about the eVTOL segment and the electric aircraft segment. So today, the Embraer X eVTOL concept, this is just a concept, so there's no actual prototype yet. But they're just the next company to sort of enter this space and have their own design. This one is pretty unique. It's got some looks like ducted fans. It's also got a number of rotors up top. So all just variations on this overall design game looking at this future market. But Alan, you said you had some thoughts as far as Tesla Battery Day, and they had some, Elon Musk shared some interesting ideas as far as how they're going to bring their Tesla electric cars down to commercial viability as far as price and ease of manufacturing, and just trying to get it out the door simply and build their factories and all this stuff around it. So what's your take on the eVTOL market as it continues to get more and more crowded and these designs continue to be complex? What have you got for us?
Well, the big picture is, I think, at least early on, is you're not going to sell these aircraft in the thousands per year. You're going to sell them in the dozens per year, probably, because of the price point. And unless you can drive down the cost of the aircraft, and that means systems and structures combined, and greatly reduce the complexity so you can lower the cost and reduce the amount of labor that's involved in making these things, and labor, tooling, raw materials, all the things it takes to do it, then what are we doing? Because what you're going to end up with is what we always end up with is a very expensive, limited, narrow market product. And if the concept is we're going to have a air mobile society, then you're going to need, at least in the United States, you got 300 million people, 300 million plus, and billions here, billions there. How are you conceptually going to think that you're going to be able to serve that marketplace if every aircraft costs $150,000, $200,000? There's just no way you can satisfy that. It's like you're in the sports car market. Mm-hmm. That's a different thing, right? So in the sports car market, when you buy a Ferrari or whatever, you got some person in there who builds the engine himself, right? And so the cost of the labor is extremely high and the cost of parts is extremely high. You're like, okay, but it's a Ferrari. But if you're trying to get to everybody can own this thing, man, you got to drive it down to the price of a car. And think about that. We can't make cars for the price of a car right now. How are you going to make an aircraft the price of a car? You have to really fundamentally rethink the way you do this. And I've seen a lot of different designs pop out. They'll look cool. They got the lights. They got the rotating blades. Well, that's great. But where the technology is going to come from is some company is going to figure out how to lower this thing down in terms of price to manufacture, which means you need to be rethinking about what materials you're using to manufacture these aircraft out of and what systems you're going to put in them that you need just to fly the thing. Mm-hmm. And we're not there yet. We're just not there yet. We see a lot of cool designs, but here's what they all say. We're going to have, I don't know, eight electric motors. You're going to have lithium-ion batteries. Bingo, bingo. Both those things are expensive. It's going to be all carbon fiber. Well, carbon fiber is expensive because there's a huge demand for carbon fiber. So the raw material is expensive. You're going to have to build tooling, which is expensive. You're probably going to hand lay this thing up. So you have a bunch of laborers that are skilled at composites, which is not cheap. Hand laying up every part. You're going to have autoclave, maybe. That's expensive. So every part of the build and putting all the systems in is expensive. Every part of the build is just huge money. There's no way to do that and satisfy what you think what the demand is, or what you think the demand is. So the design and satisfying the demand or the marketplace don't align yet. And so it doesn't really make any difference what these designs look like. So until we fix the way we build the airplanes or rethink the way we build the airplanes. Yeah. Dan, don't you see that too? Because Musk talks about that all the time for cars.
Yeah. So it's not clear what, who knows where we end up going with these vehicles. Like maybe, someday you could own one, right? Like you could have one waiting on top of your New York City building. Like that's where your little aircraft is parked. But it seems like the market most of these companies are going after is the taxi service, right? So there's going to be hubs all over the city, and they'll take you, 60 miles or 40 miles or 30 miles. But it seems like the same challenges are there. So even though, most of these companies are probably not looking to outfit, 100 million Americans with their own flying vehicle, how many of these ports could there be? what's the carrying capacity for the amount of these helicopters? Even if you have one that's the size of a parking garage, what can you have 6 of them on there? I mean, they all need space, right?
Right.
They're just kind of wide, a lot of the designs, even though they're not super big. But then,
True.
okay, so now we have 10 companies, and you're all fighting to have one of your vehicles or all of your vehicles in New York City's hubs or this hub, right? And so there's 10 companies, 20 companies, all competing for a finite amount of these EVTOLs that can be in this taxi market. So then, if you're a company and you've churned out 1,000 of these, you only sell 200 of them. I mean, you're done. And like you said, are you going to make the tooling and spend all this money to maybe only sell 500 of them in the US, or 1,000 or 2,000? I mean, it just doesn't seem like there's room for all these different companies in the market. They're all just going to fight for a definite amount of finite space. So there's definitely, it's going to be really interesting to see how that shakes out, because it just doesn't seem like there's enough room for all these players.
I don't think so. And until you lower your cost down where you can make a significant profit per each one. So if you're going to sell, just use round numbers here. If you're going to sell it for $100,000, that means you're going to make it for less than 50. And that's just to keep the doors open.
Mm-hmm.
So ideally you want to make it for 30, 20, right? And making a $20,000 anything is difficult. And that's why the Tesla cars are so expensive, in my opinion, is that they have costs in the infrastructure that they haven't gotten rid of yet. And that's why, what's the latest version? The expensive version, is it the X is the expensive version, or the Y?
Yeah, I think
you can make yourself a $100,000 car there fast.
Well, and I mean, do you see like these companies potentially, like, does Uber have to purchase an aircraft company where then they can say, okay, like, we're going to lose money on the crafts, but we're going to be essentially the airline. Like, we're going to make it back on the subscription model, on the ticket fees, on all that stuff. I mean, is that how it's going to be to survive? And if that's the case, it still comes back to my sort of idea, which is that how many companies can do that, right? I mean, if Uber is big enough, or some other company is big enough to produce the aircraft themselves, okay, now they own the helipads, they own pretty much the infrastructure. How many companies like can stay viable if they're doing that? It seems like if you don't make it, if you're not first, you're just done. Like, there's no second, third, fourth place. It's like if Ricky Bobby from that, Talladega Nights. If you're not first, you're last. So
right.
I don't know.
Well, that's true though. But I mean, being the first into the marketplace and having setting the standard for everybody else is huge, because the first one in the marketplace that defines the marketplace will typically own between 60 and 75% of it, no matter who else comes into that marketplace.
Mm-hmm.
But the problem is, no one's really defined the marketplace quite yet. I know they're talking about it, but why have, and COVID's throwing a kink at everything, but why haven't we really seen manufacturing efforts going on? We see prototypes, we see limited flight test programs with automated flight test programs where there's nobody in it. Where's the production line? Where's the tooling? Where's the concept? How are you going to keep the cost out of this thing? Where's all that detail? Because that's the thing that matters, because every other aircraft company has failed because of that. And the same thing for the airlines too. There's very few airlines that actually really make money. And you can name them. Ryanair, Southwest, and what they've done is they just have a cost structure where they've driven down their costs
Mm-hmm.
and can offer a more desirable product, and they increase their payload, right? The number of people who fly them. I'm not sure that American Airlines or United Airlines is profitable, particularly today, they're not. But is that model even profitable 10 years from now? There's a big discussion about that. So if you think you're going to create this airline sort of Uber in the sky, think twice, because the companies that do it today, very few of them make enough money to stay alive.
Yeah, and we chatted about that before, which, they said, like, hey, if we're talking about flying rooftop to rooftop to drop your kids off on the other side of New York City, it's probably just not going to make sense. It's not going to take less time. Like, you're going to have to go get in the thing. Right. You'd be better off just getting in a cab, even in a luxury, have a driver, whatever. So again, like, they have to, like you said, define that. What is their market? And then is it, shuttles from Philadelphia to New York? Is it from New York to Boston? Can they go that far? Or is it just the 60, 70, 100 miles at Long Island to New York City? And if so, how many aircraft, can support that route? Like, how many do they need? 8, 6, 12, 30? I mean, it's not tens of thousands,
right. Wouldn't think so.
So back to your original point, which is, how do you make the incredible investment, the tooling, the labor, the technology make sense?
How do you make a $20,000 aircraft out the door? That's what you need to be thinking about. And as of yet, I haven't seen it.
All right. Well, that'll do it for today's episode of Struck. If you're new to the show, thank you so much for listening, and please leave a review and subscribe on iTunes, Spotify, or wherever you listen to podcasts. Check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from the show. And follow us on LinkedIn, Twitter, Instagram, and Facebook. Our handle is @WGLightning. Tune in next Tuesday for another great episode on aviation, aerospace engineering, and lightning protection.